Hey everyone, we are going on to page 15 in our notes for trimester 2. And for page 15, we are going to be making notes on magnetism. So right next to page 15, write magnetism. And then in addition to that, in class we did a lab for page 14, and it was mapping field lines. So mapping field lines. And in that, we just put a magnet on the paper and then went around it with a compass. And wherever that needle was pointing, we put a little dash, and it kind of gave us an idea or a map of where those field lines were. And it's kind of cool. So page 15, let's go to that. So 13 and 14 over here was our magnetic field line map. And so this one is our page 15. So on the bottom here, we'll put page 15. And then we set this up for some Cornell notes. So we draw our line down the side and 2 across the top. And this little section over here where I put my name. You guys would put your name. The date, which is 11/29/21, and then what class period you have. This one's on magnetism, so let's write magnetism. Our essential question, what we're trying to figure out today, is how do magnets work? All right, so by the end of this, we should know how magnets work. And if someone asks you, you should be able to explain it to them. All right, so in class, we talked about all the different ways we use magnets. Most common answer was on the refrigerator to hang up your drawings or homework or whatever. And that's a great option or a great use for them. But there's lots of other uses for magnets in everyday life that we may not think about. So what is a magnet? Let's put that as our first word, magnet. A magnet is any material or object that produces a magnetic field. So, material or object that produces a magnetic field. And that can be like iron, nickel, or cobalt, or whatever, but it could also be electrically made magnetic fields. And so then it would be an electromagnet, but it's still technically a magnet because it makes this magnetic field. So there's lots of different uses, like I said, lifting up the garbage in junkyards, those metal objects, but those are the electromagnets because then they can turn off and drop the stuff. There's cows that they put magnets in to collect the metal that they eat so it doesn't go through them. I don't know, that was kind of an interesting one. Anyway, let's move on. A magnet is something that is also going to have 2 magnetic poles. And what that means is it has 2 ends, or it's referring to the ends of a magnet. And there's 2 of them. There's a north and a south pole. And as far as we know, there's no way of just having a north pole or a south pole. It has to be a combination of the 2. And we know that a north is going to be attracted to a south. And if I have a north and a north, they push away from each other. Same with a south and a south. Just like when we talked about protons and electrons. If I have two electrons, they're both negatively charged, they move away from each other. So same with magnets, which is kind of cool. So now that we have a basic understanding of that, maybe we could draw a little picture here. North and south. It's a magnet. Beautiful. Okay, so some magnetic objects. I think a common misconception is that everything that is metal is magnetic, and that's not true. There's actually only three things in common use that are magnetic, and those things are iron, nickel, and cobalt. There are some rare earth metals like neodymium, but those are not common. Iron can go into steel or stainless steel or stuff that goes on your fridge. Nickel is like it's used as plating a lot over top of things to cover things. And then cobalt is used a lot in drills, or drill bits, because it's a very hard material. So that's kind of cool. But those three things are magnetic. And so if I have a magnet and I stick it to one of those things, it'll pick it up. That doesn't obviously mean that it is a magnet itself. It might not produce a magnetic field, but it can be affected by it. So that's kind of an important distinction as well. So what makes it a magnet, besides obviously having a magnetic field? What produces that magnetic field? That's our question right up here, our essential question. So to answer that, I think the main thing, or the main reason, is something called a magnetic domain. And this is a region in which a magnetic field of atoms are aligned. The magnetic field of atoms is aligned. So let's write that down. So it's a region or section in which the magnetic field of atoms are aligned. So the electrons going around an atom, they might spin a certain direction, and that causes it to have a magnetic field, because the electrons moving, well, that gives us our electromagnet. So on a really super small scale, just around the atom itself, it gets a tiny little magnetic field. And if they're lined up, all aligned, that creates a stronger magnetic field, and that gives us our magnets. So let's draw a picture to help represent that. So I'm going to draw a box, and then kind of just go randomly, I guess. So this is, we're kind of representing that domain, that region. And let's say I have some of these arrows kind of pointing in the same direction. Maybe a few of them aren't, but for the most part, they're kind of pointing this way. So that would give this overall a pretty weak magnetic field in this direction. So this would be maybe north and goes around, make it south. If they were all aligned in the same direction, then it'd be a stronger magnetic field and a stronger magnet. And if they're completely scattered, that would give us some of these magnetic objects that might be able to get picked up by a magnet, but maybe aren't a magnet themselves. All right, so our last word for this page is magnetic field, and that's what we mapped on the previous page with a magnet and a compass. So let's write that down. Magnetic field. So this is a region near a magnet that I think I have that worded poorly. I'm just going to leave it. That's fine. So a region near a magnet that can be detected. And the thing we're using to detect it is a compass. And I don't know, it just, that doesn't seem like a real clear definition. That's going to bother me. Whatever, we're going to keep moving on. I'm just not happy with it. Whatever. Field lines. Something about those field lines. If they are close together, that means it's a stronger magnetic force. Oh, I betcha. Okay, so a region near a magnet that can be detected by a compass, but that's just another magnet. I'm just going to say by a compass. Oh. Took me a second to remember how to spell compass. Awesome. So just a real basic drawing. Just a copy of the one that was over here. So if I have a north and a south, what we did is we put dash marks around the compass, and what it had ended up doing was make something like this, where it was kind of almost like a butterfly. I know that's going to be really hard to copy. I apologize. But we see that they line up with this north and south, but on the sides it starts to curl back in. And so technically it's going to go out here, come back around and go back into the south end of the magnet, which is kind of cool. It kind of makes that loop. So these field lines are going to be really close together towards the ends of the magnet. So those field lines are really close, so it's a stronger magnetic force. Obviously, if I put something right at the end of a compass or a magnet, it's much stronger than if I'm out here where they're going to be further apart, and then it makes it a weaker magnetic force. Anyway, that's our quick thing on magnetism. And we'll move on to gravity for our next page.